Welcome and thank you for joining us for the Connected You Intelligence. So for those attending today, we who are participating as the presenters acknowledge the traditional owners of the land where we as the presenters live and work today, that being the Wurundjeri people of the Kulin Nations, and we pay our respects to elders both past and present in this country that we know as Australia. So my name is Garry Williams. I'm the creative producer of innovation at Melbourne Connect, which is part of the University of Melbourne, and we're here to deliver this event for you. The Connected You is a new event series being delivered from 2020 onwards. It was intended to be in person, obviously, but we've shifted online and we'll deliver a number of really dynamic topics over the course of this year, very much firmly focused on the interaction between humans and technology. I'll introduce our speakers in just a moment, but you'll also see another presenter at the top of the screen. That's Zara Zainal, who's joining us. I'll throw to Zara soon to tell us what she does, but she essentially produces graphic recordings of events. They're a great storytelling mechanic for events, and it shows the flow of where the conversation goes. So very powerful and very amazing, both in person and online. So what is Melbourne Connect? I'm going to share a screen for you if I can. Melbourne Connect is a forthcoming innovation precinct which will be launching towards the end of this year and the start of next year. It'll be located on the corner of Swanston and Grattan Street, and it's a connected innovation ecosystem which will essentially co-locate university researchers, industry partners, emerging talent, inventors, creators, and so on. So located in this precinct will be the Melbourne School of Engineering, the Melbourne Entrepreneurship Centre, which also includes groups such as Melbourne Accelerator Program and the Translating Research at Melbourne Program. Science Gallery Melbourne will be based there as part of the global network of science galleries all around the world in locations including London, Dublin, Detroit, Rotterdam, and so on. We'll also have a co-working space, Fab Lab maker space, numerous event spaces that are ripe for conversations exactly like these. So we're really excited to deliver this, well, basically massive precinct, which will hold up to 3,500 people when it's in operation. So we are online at melbconnect.com.au. Do check out there if you want some more. But fundamentally, we're focusing on the content today. So we're here for the Connected You, which follows on from another event series we launched this week called Understanding 2020. That was a collaboration between Melbourne Connect and Melbourne School of Psychological Sciences. That school also has some additional context and reference for today with Simon Dennis. So today we're here to discuss intelligence and information in an increasingly technologically enabled society. So our ability is to gather large amounts of information is no longer a luxury, but an expectation in our lives. Information that determines the choices and decisions we make, and information which can be generated by highly complex means. So I'll ask our presenters to give a wave as I briefly introduce them, but I'll dig a bit deeper and explain their background, and they'll further elaborate as they begin their presentation. So we have Professor Simon Dennis, who's the Director of the Complex Human Data Hub. Thanks for joining us, Simon. And also Associate Professor Tim Miller. Tim is the Co-Director of the Centre for AI and Digital Ethics here with us today. Great to see you, Tim. So we have our graphic recording artist, Zara Zainal, with us today. Do you want to say hi, Zara?
Hello, everyone.
Now, Zara's done plenty of graphic recordings in person before, and now she's doing the online thing, and really appreciate it. But did you want to briefly explain what you produce, Zara?
Yes, so I will be drawing the key points from both Simon and Tim's presentations. And if I just cut over to my iPad here, so you will be able to see me drawing. And this will be emailed out to you as a reminder of what was talked about today.
Fantastic. Yes, very excited to see it. Thank you so much. All right, well, without further ado, we've done the necessary introductions and the housekeeping. So what we're going to do now is we'll throw to Professor Simon Dennis. So Tim will come just afterwards. But Simon, before you begin, I might just do a brief spiel about what you do within the University of Melbourne. So, as I mentioned before, Professor Simon Dennis is the Director of the Complex Human Data Hub, sometimes known as CHDH, which is a part of the Melbourne School of Psychological Sciences. The aim of the school, of the Data Hub, is to develop computational behavioural science bringing together computational methods to bear on big data to better understand psychological processes. So, AKA, we're focusing on the science behind how we measure human experience and behaviour. Simon is also the head of the Memory and Language Lab in the Melbourne School of Psych Sciences, and his research utilises large-scale real-world data, experimental paradigms, and computational modelling techniques, which he'll explain in further detail now. So, Simon, take it away. We'll see how we go with the tech, and sing out if you need anything.
Okay, well, thanks very much, Garry, for inviting me along to speak. And to give you a bit of an idea, what I'm going to talk to you about today is, firstly, just to give you a little bit of an idea about, I guess, some of the promise of new methods of data collection and in the psychological and behavioural sciences. And then I'm going to pivot to what I think is one of the fundamental kinds of problems that we need to address if we really want to realise the full potential of these kinds of methods, and that's how are we going to deal with people's privacy. So as Garry mentioned, I'm the director of the Complex Human Data Hub in Melbourne School of Psychological Sciences. I'm also the CEO of Unforgettable Research Services. Okay, so I apologise to the people who've heard me speak on this topic before, because there's going to be some repetition. And in particular, my byline that I say nearly every time I give this talk is there has never been a better time to be a psychological scientist. So what we've seen over the last decade or more has been this dramatic increase in the amount of data that we're able to collect about individuals. And that's an increase in the size of the data, but also an increase in the density and the specificity of the data in relation to how it captures the lives of individual people. And in my mind, this is a really major change for the way that psychological science is going to be done going forward. Psychological science has had some wins along the way, but I think it'd be fair to say that as a science, we perhaps haven't had the same kind of impact that one might anticipate given the nature of what we study and the relevance of that to so many different areas of endeavour. And so why is that? Well, I think part of the reason that we've kind of struggled is that our ability to actually characterise the many different factors that influence people's decision-making, their emotions and so forth, has been fairly limited. A lot of psychological research has taken place in the laboratory. There's only so much that you can get when you're in these very controlled conditions, because a lot of what influences people's behaviour depends upon the nature of the environments in which they are operating on a daily basis. On the other hand, we have a lot of survey research, but again, it tends to be fairly circumscribed snapshots of people's beliefs at certain times without a lot of the context. And I think that has made it really difficult for us to be able to make the kind of progress that we'd like to make. Now, of course, that's all changing. The provision of smartphones and sensors that they contain, the internet and access to all of the services that are on there, the Internet of Things, wearable devices, all of these are providing us with a much more detailed understanding of the lives of particular individuals. And with that, I think will come the potential to understand human behaviour in a much more detailed fashion. So as I say there, to be able to explain, predict and influence human action. And of course, science is kind of catching up in this respect, because tech companies like Google and Apple are well advanced on these kinds of methods and are explaining, predicting and influencing human behaviour as we speak. And of course, many state actors are doing so as well. So there's, but I think we're really at the start of that, and I think it's a very exciting time to be a psychological scientist, and that's really what we're about in the Complex Human Data Hub. about marrying these new data methods with existing psychological theory and new data sources to build computational models of human behaviour. So that's what we're about. The link to the Complex Human Data Hub site is there at the bottom of the screen, and I encourage you all to go and have a look. We've got, you can see all of the people who are involved in the hub there. There's news items, there's all of the events that we run there as well. So please feel free to go and take a look at what the CHDH is all about. Now, so that's paints a very rosy picture of the use of human data, but of course there is the flip side to that, and that's the fact that a lot of what we're working with is extremely sensitive and private data. And what we've found over certainly the last few years is that as the data sources get larger and become more specific, the very power that we're looking to be able to use in the CHDH is also a source of potential problems. And so in particular, the most useful data is often the most sensitive data, most private data, and we need to really come up with better ways of being able to deal with that data. And so there's probably no better example of that than what happened with Facebook. So I imagine many, if not all of you, are familiar with the Cambridge Analytica scandal. So this was where 87 million Facebook profiles were taken and potentially used to influence the US presidential election. And so the kind of central player in this saga was Alexander Kogan. He's a social psychologist who studies personality. But apart from being a social psychologist, in every other way, Kogan presented as a legitimate scientist. So he was a research associate. Sorry, that was a joke in case people didn't get it. He's a research associate at Cambridge University. Was a well-published individual, and he developed this online app called This Is Your Digital Life, and was testing the big 5 personality dimensions. About 270,000 people use the app, but the way that the app was designed, it allowed people to actually opt in all of their contacts as well, and so that's how it came to get such a huge amount of data. Now, I think this story really illustrates a couple of the key aspects of data. So I'm not going to go through this slide in detail, but this essentially outlines how it was that the data got from Kogan through into Cambridge Analytica and was ultimately used by Steve Bannon and others to at least attempt to influence the US election. Now, what this does, I think, is this saga illustrates is 2 critical components. So the first thing is that Kogan did not hack the system. So it wasn't some kind of security breach from the outside where he managed to get in and find this information illicitly. He was authorised to have that information, but then the data, he transmitted the data to places where at least some people would argue it shouldn't have been allowed to be transferred to. So, so the first thing to note about that is that he wasn't a hacker; he was an authorised person. And so, when we're thinking about the control of data, we have to allow for the possibility that we're going to have inside actors that may not operate as they should. Secondly, the other key thing about data, right, is that once you've let it out, it's pretty difficult to get it back with any kind of certainty. So it's purported that all of these Facebook profiles have now been deleted, and they've certainly been deleted off some machines. But how would you know that there aren't other copies out there? So really, if we're going to be serious about protecting people's privacy, then we have to find ways to ensure that not even the researchers who are doing analyses are able to just take that data and move it without some kind of restrictions. Okay, so what I want to argue is that really requires us to think quite fundamentally about the nature of the tools that we operate. So, you know, I use Python, a lot of people use R, a lot of people use MATLAB. None of these languages have really been developed with the notion of privacy preservation in mind. So this is kind of my a kind of simple example. So let's say you've got the my emails, you go through, you do a search for me, you find out some email that, you know, maybe I wouldn't necessarily like you to have, and it's very hard to stop that kind of thing happening the way that we currently operate with data. So for the most part, people just take data sets and they download them onto their own machines. The languages that like R and Python and MATLAB and so forth are actually running on their own machines. And so stopping this kind of exploit is really quite difficult. And so I think that you know, as the data sets become more sensitive, we're really going to have to take this seriously and come up with alternative methods. So that's what we've been working on as one of the projects in the Complex Human Data Hub. And what we've done is work to develop a new language called Private, which is designed to create this barrier, to allow researchers to be able to run analyses without seeing the underlying data and without being able to reverse engineer or at least easily reverse engineer the results of any given, or the data from any given individual. So the language is called Private, and here are some of the kinds of characteristics of it. So one of the things that you need to do if you really want to take privacy seriously is you need to have a very tight coupling between the data and the analysis. So I said before how you know, it's not really sufficient to be able to download the data and have it on your own machine and run the analyses on your own machine. And so what Private does is it has this tight coupling between data and analysis. So the data stays on the central machine, the analysis is always run on the central machine, and then what you get is a shell which allows you to interact, but you don't ever get to decide what the configuration of the data analysis package is, or the direct access to the data itself. The key aspect of Private is that any result that is released has to be tested before that release occurs. And so every value that is visible by someone interacting with Private initially goes through a set of privacy tests to make sure that it's okay for that that person to see that data or see that result, and if not, it just comes back private. So so that kind of gives us that additional level of control that we would normally not have. Private's both a probabilistic and a deterministic language. So for those who are familiar with Python, then a lot of what you'll see in this coming slides will be familiar, because it's basically built on Python, and so a lot of the syntax is the same as Python. But in addition, that's not enough, right? So if you just had Python, then you'd have all of the exploits that Python allows. And so what we've done is we've brought together a kind of bugs, JAG, STAN language. So for those who are familiar with Bayesian probabilistic programming, these are all probabilistic programming languages. What we've done is mesh the syntax from Python and from these probabilistic languages in order to create a composite that gives us the control we need. It's a declarative language, not a procedural language, and that's important for technical reasons. It makes it much easier for us to do the underlying reasoning that we need to about variables to determine their privacy status, because the privacy status of a variable is always, given a program, is always the same. It doesn't change as a function of state. And so it's a lot easier to be able to do this for a declarative language. However, it does allow incremental definition. So like Python and R, where you can just type in individual statements and see what the effects of those statements are, you can do that in private as well. The privacy analyses that we do are very large scale. They require quite a bit of computation, and so private automatically parallelizes in order to allow all of that to happen. And it's really designed for big data kinds of processes where there might, it may not be sufficient to have a single machine dealing with the data. Uses a list of fairly standard technologies: Arpeggio, PyMC3 for doing Bayesian sampling, Dask for parallelization, and Redis for data storage across multiple machines, and it's open source. So what I'm going to do is just give you a little, very rapid introduction to it, and then you can kind of come back to me with more questions later if you want to dive deeper. So as I mentioned, there's a very tight coupling between data and the analysis in private. So there's no installation or setup. It's assumed that whoever the data holder is already has a computational infrastructure, and that the data will be held on that infrastructure and the analyses will be conducted on that infrastructure. And so that creates prevents a lot of the possible exploits that would otherwise be could be done. And then, so you just log in, you need access, you need to be granted access, you log in and then you use that. And as a consequence of that, you never load data. So the data just exists within the environment as soon as you log in. To give you just the briefest of examples, so here what we have is an example of some private code. So in this first line, what we've done is we've created a variable called reigned, and we're just trying to figure out, we've got a list of events. This list of events was one that is the data that is being held by this system, and so that exists a priori within the system. And what we're doing here, for those who know Python, this is just a list comprehension, and we're just going through all of the different events that have been stored in this data structure and figuring out whether the weather was rainy at that particular time. So that's just a big list of trues and falses. And so we put that definition in. SV just stands for show variables, so we do that. Now you'll notice over here, so this is just the code again. Over on this side is the value, but in this case, we're out of luck because events was a private data field, and reigned is a deterministic variable calculated on the basis of events, and therefore private concludes that it's not generally okay for you to see that, and so it's not showing you. Okay, so that's not going to be much use for your analysis. So what can you do? Well, what we can then do is define a very simple little probabilistic model here. So we're going to take our variable reigned, so this is our data, and we're going to say define that to be distributed with a Bernoulli distribution with a rate parameter R, and then we set up a prior here. R is distributed with a uniform probability between 0 and 1. As soon as that little probabilistic program has been defined, private realizes that all of its dependencies that need to be defined have been, and so it starts computing. And so down here we're showing the variables again. Reigned is still private, and but the R parameter, the rate parameter, which is determining how often, how probable is it that it's raining on any given day, that parameter, that parameter is being computed. So private's realised that the model is complete. And so it's gone off and started doing probabilistic samples of the R parameter. And promise this is the last code slide. So up here, it's actually finished doing the computation of the samples, but at this stage, it doesn't know if that's okay, right? So it's got some samples, but once you have a set of probabilistic samples from this variable, you still don't know for sure, is that set of samples too sensitive to any given individual? So at this point, Private's saying, well, I don't know yet. I'm off doing calculations to figure out whether it's okay to release that information to you. And then subsequently, we do an SV again, and now we have some values. So it's determined, yes, it's okay. And so I'm going to show you those variables, and then you can calculate other deterministic functions on the basis of those variables. So in this case, we've done the mean of those samples that we calculated of R. And so we've found out that it rained about a third of the time for this sample that we have. So that just gives you, a very brief introduction to how the language works. So what's going on when you're underneath the hood there trying to figure out whether it's okay to release these probabilistic samples that we have? So what it's doing is it's going through and it's actually running the computation, the analysis, multiple times. So it runs the analysis with everybody in. So we've got our 4 subjects who are in this experiment up the top here. And what we're trying to do is say, calculate the amount of blue that they typically wear. And so, so it starts off by doing the sampler with all people in. And so we get a distribution here for that. And then it goes through and it says, okay, well, what if I redo that calculation, but we're only with these 3 people in? What distribution do I get then? What if I do it with these 3 people in? What if I do it with these 3 people in? What if I do it with these 3 people in? So what we're looking at is how sensitive is the distribution of samples that we get back to the exclusion of any given individual. So, so if the distribution of samples we get is very sensitive to a given individual, that means that those samples are probably not safe to release, right? Because now they're providing information about one of those individuals. So in this case, we'd say, no, it's not okay to release because we compare this distribution to the all distribution. We'd say those 2 are not close enough to each other. Therefore, we can't release that data and it would come back private. Okay, so that's like the very rapid introduction to the way that Private works. And Private's one example, but I'm sure in the future we'll see many more examples of languages like this, where the aim is to try to protect people's privacy right down in the guts of the language. So the take-homes from me for today, firstly, behavioural science is undergoing revolution. It's happening, it's important, it's going to change the way that we go about doing our science. And that's being driven by the availability of these big, dense data sets that allow us to get much more information at much finer grain detail, which I think is really necessary in order to truly understand how people think and act and feel, by the way. But the current state of privacy preservation and data analysis is not close to good enough. And in fact, I would say it's kind of not even there at all for the most part. So most of the languages that we have really don't do anything at all to try to preserve people's privacy. So Private really works to try to create a specific mechanism which allows us to, individuals, enterprises, institutions to take privacy seriously. So I just wanted to finish with a couple of pointers to other things that are happening in the near future. So I'm giving 2 webinars in the coming weeks, one on the 13th of May and one on the 27th of May, where I'll be going into some of these topics in much greater detail. So please feel free to sign up for those if you would be interested in learning more. And I just wanted to end with a plug for the COVID Safe app for those who haven't yet downloaded it or contemplating whether they should or not. So from my perspective, it's a good idea. I think there are problems, but the problems are outweighed by the advantages of the way it's been implemented, and I would advocate everybody going out and downloading it now. So that's it from me, Garry.
Wonderful. Thank you, Simon. Thank you so much. Yeah, that was fantastic. I was going to briefly raise a question of, obviously we're talking about data, etc., and particularly within this COVID-19 context. I know you were out there in the media a little bit speculating about it. So how has COVID, I guess, informed or shaped some of Complex Human Data Hub's strategy for this year in light of what's happened very, very suddenly?
Yeah, well, so I guess in multiple ways. So one, obviously, like a lot of behavioural scientists, we're being forced online, and so right across the Complex Human Data Hub, there's been this big effort to make sure that everything we do. I mean, we're already largely online, but now that process has been accelerated dramatically. More specifically, I guess the hub's been involved in this process of looking at what are the privacy dimensions of the COVID app and how are people responding to those. So we have a big study over 8 different countries at the moment where we are assessing people's privacy attitudes, and those are and we've been doing that for a while now. So we've had 2 waves in Australia, and basically looking at different scenarios before the app was actually released and looking at how people respond to those scenarios, asking them a whole bunch of questions about, to getting them to rate where the scenario sits on a number of different privacy dimensions, the sensitivity, access to data, and so forth, then getting them to re-rate how they feel about those scenarios. And so essentially looking at, well, how, what are people prepared to do, and how does that change across cultures and so forth. And it's been fascinating. The thing that I found most surprising about our data collection is just how different Australians feel about this relative to their counterparts in the UK and the US. So Australians are much more ready to give up certain level of privacy than what people in the US and the UK have been. So that's been interesting. We now have the app, of course, and so we're just about to start surveying people about their attitudes to the existing app. So we'll see how things are progressing now.
Sure, and I did see that yourself and some academics have remarked that I guess in terms of that culture, if the public felt that there was a forced expiry on that there would obviously be a higher likelihood of downloading, up to 10%. Was that right?
Yeah, that's right. And I mean, it's kind of an interesting question. It was there because we also had a scenario where we were talking about, how would people feel if the government was operating directly with telecommunications companies and other service providers to gather information without actually having it as part of an app and so forth. And so there, right, then the sunset clause kind of idea is really important, because the people's willingness to accept that is going to depend on the extent to which they're confident that at some time it's going to stop. But with the app, it's kind of a little bit less of a fundamental question, right? Because you can always just delete the app if you want to stop. So yeah, but still, yeah, big changes depending on sunset and so forth. Yeah.
Okay, wonderful. Rajwinder has asked, how can we sign up for the coming webinars? The ones you flashed up on the screen. So look, I'll publish out through Melbourne Connect Twitter, for example. What promotional channels will you publish those webinars out through?
Yeah, so that's a good point. So they will be on the Unforgettable Research Services Twitter feed. They're also coming out on my personal Twitter feed, so you should be able to get them from either of those places. Or just feel free to email me at simon.dennis@unimelb.edu.au.
And it's at Simon John Dennis on Twitter, isn't it?
Yes, that's right. Yep.
remembered your middle name. There we go.
Very good.
Simon, so just to wrap up before we launch into Tim's presentation, and thank you again. Just wanted to know, so what are the main sort of, I guess, what does 2020 entail, looking a bit further ahead for Complex Human Data Hub, in line with strategic objectives, emerging partnerships, future locations, and so on?
Yeah, so we are going to be part of the of Melbourne Connect, and so there's a little bit of uncertainty about when we'll actually be moving in, but at the moment it still looks like it's on track for December or soon after, and so that will be a big milestone for the Complex Human Data Hub, and we're going to be co-located with CADE, I believe. So that'll be exciting to be, and also the computer science. So it'll be exciting to be, in the same context as those guys. So we're really looking forward to that. And more generally, I think, a lot of what we're looking at now, right, is kind of key business for the Complex Human Data Hub. How does people's behaviours change, around their daily lives and their attitudes and their emotions as they're going through this very unusual period. And so we have multiple projects that are looking at that. How does that play out in a defence context as well? So all of that are the kinds of areas that we're moving in at the moment.
Wonderful. Look, thank you so much for your presentation. I really appreciate it. It won't be the last time we have yourself or the team involved, but yeah, really looking forward to seeing how this develops over time. So thank you once again. You're off the hook.
Okay.
So for now, we'll throw to Associate Professor Tim Miller. So thank you for joining us, Tim. I'll just highlight you. So we've got you on the screen. There we go. So good to see you, Tim, and thanks for bearing with us. I do know that you would regularly speak in the public realm about AI as part of your research and work, and very regularly facing industry in that perspective, which is obviously a very highly important part of your role. What I'll do the service of running through your bio really quickly, so you don't have to do it. But then, of course, please then deep dive into the work that you do day to day. So, Associate Professor Tim Miller, he's the co-director of the Centre for Artificial Intelligence and Digital Ethics, and he's the Director of Learning at the School of Computing and Information Systems. That school is part of the Melbourne School of Engineering here at University of Melbourne. So the centre, which is also known as CADE, facilitates cross-disciplinary research, teaching and leadership on the ethical, regulatory and legal issues relating to AI and digital technologies. So Tim's particular primary interest lies in the area of AI, and in particular explainable AI and human AI interaction. So he definitely crosses that intersection between AI, interaction design, and of course cognitive science and psychology. So we welcome you, Tim, and thanks so much for appearing today. If you'd like to take it away, we'll get your screen shared.
Thanks. Can you hear me okay?
Yes. Yep.
Good.
Thank you.
So can you see my screen?
And yes, can see it as well.
Good. Yeah. Okay, good. So thanks very much there, Gary. So the title of my talk's one that it's actually for a keynote talk that I'm giving next week. And it's also the title of a paper that I wrote a couple of years ago with some colleagues, and it's Explainable AI, Beware the Inmates Running the Asylum, or How I Learned to Stop Worrying and Love the Social Sciences. And so to explain a little bit the title, the second part of the title about how I love to learn the social sciences is a bit of a play on a movie that you might have seen, a Peter Sellers movie about World War II, the Dr. Strangelove it's called. But the main part of the title is The Inmates Running the Asylum. And so this comes from this book here by someone called Alan Cooper. And Alan Cooper wrote a book, I think it was 2004 there. In about 2004, he wrote a book saying, we've got lots of software in the world, but why is so much of it just so crap to use? And he kind of studied it, and he came up with this. His opinion was that the problem was that the way that we actually interact with the software and the people who design that is being left up to software engineers. And software engineers don't really know how people want to use software. They know how to write software and they know how they want to use software, but they don't know how other people want to do it. And so he kind of came up with, the opinion, and he came up with some tools, things like personas, if you've used personas in marketing or in interaction design. This was the book that introduced personas, that really we should be getting people other than software engineers to design this, or at least software engineers should have the tools in order to sort of empathize with other people and figure out what they want. And the sort of inmates running the asylum is a way that I think explainable AI was going. I think we're successfully pulling it away there, that we had this idea of explainable AI, which was artificial intelligence that could make a decision and could explain why it made that decision. And we'll talk a little bit about why that's important in a bit. But I was really worried that really it was only the artificial intelligence community that was interested in this problem, but actually it was a much more cross-disciplinary problem. And I'm going to talk a bit today about some examples of showing you how that can be done, why it's important, and the link to sort of the Centre for AI and Digital Ethics, and also my own lab here today. So we've got a big problem in AI right now. We've got lots of problems, and the problem isn't, lack of funding or lack of interest in it. It's completely hyped at the moment, and there's lots of work going on around AI. But the problem's in what my friend and colleague Virginia Dignam calls the art of AI. And we're not talking about the ability for AI to produce original art, which is, yes, a big problem and a challenge. Well, a challenge that's maybe not such a huge problem, but it's a challenge. It's the art refers to accountability, responsibility, and transparency. It's an acronym. So accountability is effectively that when you make decisions using whatever mechanism you work, could be an automated decision tool, or as a person, somebody is ultimately accountable for that decision. And when you've got an automated decision making, how can you make somebody accountable for a decision, and who is accountable for those decisions when they're sort of made jointly between machines and organizations who produce them and the people who validate them, and all these types of things here. Responsibility refers to the responsible use of these things. So do you ensure that, for example, if you're making automated decisions or decision support systems, that they're fair? For example, they don't disadvantage a particular minority group. So a really great example of this was Amazon training a machine learning system. They took a whole lot of CVs from 10 years worth of recruitment, and they trained a machine learning model that said, okay, we want to filter out applicants based on our previous decisions that we've made with CVs. And they effectively found that women didn't get shortlisted anymore here. And this wasn't really a problem. It wasn't a problem with the machine learning algorithm. It was a problem with the data they used. They weren't shortlisting enough females in the previous sense. So, but at least the algorithm figured out, sort of revealed this bias here, and they decided to take this algorithm out of use. And then somewhat stupid, they just went back to the old system, which was actually where the problem was in the first place, that they could hide it there, I guess. And transparency is around when you design these things, can you make sure they're transparent in that when someone, for example, is subject to a decision, are you able to explain to them, this is the data that was used, this is how we trained the system, this was the input that we got, this is how we validated the system. So giving this to data subjects or regulators and these types of things here, that it's kind of clear that how you went about things. But I'm going to sort of delve a tiny bit into explainability, which is my area of expertise. And that really fits around this idea of accountability here. And the question becomes, if you're holding someone accountable for a decision and they're using an algorithm to help at least automate part of that decision or inform part of their decision, can they really be accountable if they don't understand where the decision came from? Can you really hold them accountable? Is that fair to do so? And if we think it's not, then probably we need to be able to let them interrogate why decisions have been made. And this is what the field of explainability is trying to do. It's trying to say, okay, you can make a decision, but really we need people to understand why that's the case. And it's important for two reasons, right? The first one is just general, from I guess almost an individual perspective, it's trust. So this is a quote here from a paper from a PhD student, Kirsty Stubbs, from 2007, and they were looking at using automated vehicles on Mars, and they were doing trials in the Utah desert where they had some geologists who were using this automated vehicle that was roaming around and picking up rock samples. And effectively what they found was the science team, the geologists, they were more focused, or they're less focused on what's the robot doing and more on why is it doing that. So they were questioning a lot of decisions here. And they found that the more autonomy they gave to the robot and the less control they had, so they could choose to drive around, pick up things, or it could make some of its own decisions, the more autonomy they gave to it, actually the greater the workload became. And this was supposed to help reduce workload, but it just became more because they spent more and more time questioning decisions. And we see this all around. People deploy algorithms, then just people don't use them because they spend so much time trying to figure out, why did it make that decision? I don't understand why it made that decision. I'm an expert in this and the decision is different to what I've given. Surely I'm going to trust my own judgment over a box that's sitting in my laptop. And the second one is, I guess, less individual and more at a societal level around ethics. And this is what I'm talking about here. Here's a quote about accountability of AI under the law. And so if accountability is the ability to determine whether a decision was made in accordance with some laws or some procedures here, then we need to be able to look into the decision-making mechanism completely and not just say, well, this part of the decision was made by an algorithm and we're only going to interrogate the stuff that the person who gave us the decision thinks. So that's what we care about. And so the sort of scope of explainability, I see it sort of looks like this. And this is just from a paper I wrote, in that it's kind of a triple-pronged problem here. Obviously, people in artificial intelligence are going to be interested in this. But really, when you think about, it's about engendering trust and helping people understand decisions and helping people make better decisions, then clearly you have to integrate this with the cognitive and social sciences, who really do understand how people make decisions and understand how people understand things. But also there's a bit of human-computer interaction here, or interaction design. So we can understand how people make the decisions, we can make decisions with algorithms here, but how do you actually come this back and forth interrogation? And that's the field of human-computer interaction. But the observation I made in the asylum, the inmates running the asylum paper was, explainable AI sits right in the middle in this field called human AI interaction. And that's the thing that sits in the middle here. Clearly sits in that realm there. But most of the papers, almost all of the papers we saw, were just sitting in artificial intelligence. They were being published in artificial intelligence conferences and journals by artificial intelligence researchers, only citing artificial intelligence papers. And worst of all, they were never really doing studies with people. So the trend we're still seeing this trend here is to say we have a particular algorithm and we have an explainability module in it, for example, that can help people understand how the decision came about, and they're never really testing that claim. They're running some computational experiments to show that the explanations are small and compact, and that's about it. And we sort of made this point, and we published a paper, and I mean it got a little bit of traction here. And I really got worried that this was just sitting in artificial intelligence, and I'm trying to convince people that maybe they should branch out into the cognitive and social sciences and HCI. And so right now we have an ARC grant, Australian Research Council grant. Myself and Liz Sonnenberg are the AI people, and we have Frank Vitire and Eduardo Veloso from our HCI lab in our school, and Piers Howe from Melbourne School of Psychological Sciences. So we're really embodying that. So I just want to give you a quick example, infusing the social sciences. And I was going to run a little poll here, which you can usually run on webinars, but it didn't seem to work this webinar. But maybe you can just think about it yourselves. But here's a simple example that comes from a paper from Tanya Lombroso, who's a cognitive scientist who studies explainability. Imagine you have these causes that lead to symptoms. So if you stop exercising, you'll gain weight. If you have mono, you have fatigue, stomach virus, nausea, and if you're pregnant, you'll have all three of those symptoms there. And in the right-hand column, you've got this probability of this patient Cheryl has these causes, right? So Cheryl has weight gain, fatigue, and nausea, and a doctor, for example, thinks, yeah, it's 80% likely she stopped exercising, 50% that she's got mono, 50% she's got a stomach virus, and 15% that she is pregnant. And the question is, which is the best explanation here? Should it be, well, Cheryl has stopped exercising and has mono and has a stomach virus, or should it just be she's pregnant? Just Just think about that for a second. Which one your preferred one is. Now, I do this survey, I've done this survey a few times, and you get mixed results. Some people say, well, the number one, those three things put together. Because if you multiply those probabilities together, you get that it's 20% likely she has these three things. And that's more likely, so that's clearly a better explanation. But actually then about half of the audience says, no, I just prefer pregnancy. That's much simpler. And so it turns out people prefer simple, smaller causes to explain things, and they prefer causes that explain multiple things rather than multiple causes that explain it, even if the probability of those is much lower. So this was only a small study, it's a toy example, but surely we should be taking note of those types of things when we define our own explainability algorithms here. And then here's an example of not infusing the social sciences. And this is a non-trivial example of what are called saliency maps. So saliency maps are things that on the left here, we have an image and we have a deep neural network that's classified this image as having a cache machine in it. So this has got a cache machine in it here. And researchers in machine learning came up with this idea of saliency maps for explaining how it came up with how this came up with the fact that it's a cache machine and various other things. So on the right here, we have a saliency map for this cache machine. And you can see here, I mean, I don't have a pointer, unfortunately, but you can see here on the right-hand side, you can see the part of the cache machine being highlighted, and there's the outline of a person using it, which is probably what it saw in its training thing. And for a long time, people said, yes, this explains what we're trying to do. But what they didn't sort of realize, if you look in the middle of the image, just down a bit, there's a wheel from this little cart, that's in here. And that's actually the strongest part of the thing. And so some researchers, including Bean Kim, who's referenced here, said, well, why is the wheel there? I wouldn't see a wheel very often. And they went and did some research, and effectively they showed that these saliency maps are meaningless. They really just detect edges of images here. So it's detecting an edge of anything that's in this image, not just an ATM. And the problem was, really, we saw that the researchers who were conducting these studies on saliency maps, they were just seeing what they wanted to see in it, right? So they said, yes, look, an ATM here is highlighted, the cache machine's highlighted, that explains the important inputs in this image here. And so my claim would have been, actually, if they had collaborated with, for example, a cognitive psychologist, they would have said, well, you can't make that claim. That's a really poor claim. You have to go and do some experiments to show that this does actually improve people's understanding of how this decision was being made. You can't just look at it and say, I understand this, and publish it. And this is published work, getting published in machine learning and AI conferences and journals. People are saying, yes, they run their algorithm, they show some examples, and the reviewers are saying, that looks good, that's convincing to me. And my push was, no, we have to stop this, because really people spent a couple of years chasing down this saliency map idea, and it turns out that for the most part that they're rubbish. It seems that the community hasn't learned very much from this. Now they're just looking at better saliency maps that aren't as rubbish. So what's the answer? Well, infusing the social sciences. This is a paper I wrote when I went on sabbatical in 2017. My first task was, well, I'm going to read a few papers around cognitive and social science, because someone must have researched this kind of thing. And turns out lots of people have researched lots of stuff on it. So I summarized around about 200 of the most salient papers, and I published this paper of it. And this has been quite impactful since it's been published in 2019, maybe cited 500 times now. And people, you can see in the community, people have really started picking this idea up. They're starting to run more user studies. They're starting to build their understanding on cognitive and social science, and the HCI community has really picked this up as well. And so in my lab, we really take a cross-disciplinary approach here, and all my students are doing studies, human studies. Some of them are collaborating with people outside of our school. And so in the Centre for AI and Digital Ethics, we're taking the same approach to ethical problems here. And this is a new centre, so I don't have too many projects that we can kind of refer to yet here, but this is a sort of selection of the people who are most involved in the lab here. Myself am a director, but the co-director, Jeannie Patterson, is from Melbourne Law School. She's a lawyer, and she's got interest in digital decision-making and its impact on consumers. Our Special Projects Officer, Adam Lotters, he has Bachelor of Economics and Master of Public Policy, and he's got a JD as well. Gabby Bush, who's our other project officer, She's got a BA in political science and a master's in developmental studies. And down the bottom, we have our 3 postdocs, Kobe, who's also a lawyer, Simon, who is a former veterinarian, come medical ethicist, come digital ethicist, and Mark, who's a computer scientist, but really understands philosophy better than any other computer scientist I've ever seen. So we're building this very multidisciplinary team in the same kind of thing. And this is just the people that are the main parts of the centre. The centre itself spans Melbourne Law School, Melbourne School of Engineering, Faculty of Arts, Faculty of Science, and we're drawing on people from those schools. So, for example, a project we're trying to get kicked off, trying to start right now, we've almost got funding for, has some people, political scientists from the Policy Lab in Arts, working with Mark to solve some interesting problems on gender bias. And so to advertise an upcoming event with Cade, if you're interested, on Friday the 22nd, 12:30, we've got an event called a pub lunch with Cade, and this is us taking a photo of ourselves in the pub or not in the pub. This will be an online event, obviously. If you're interested, go to eventbrite.com.au and just search pub lunch with Cade, and you'll be able to find us and register. We've got almost confirmed 2 very exciting speakers for that, and probably a 3rd one as well for that pub lunch. And this is going to be a pretty informal webinar where we're going to talk about ethical problems and the cross-disciplinary approaches that we're taking. So if you're interested, please register. So to get out of that talk, what I just wanted to really promote is around cross-disciplinary research, and I showed a couple of examples from my own research area, explainability, on why it's important, but I think this applies just as well to ethics problems, digital ethics problems. Thank you.
Wonderful, Tim. Thank you so much. And we've got them right to the time now. So for everyone still on the call, we're just about to wrap up, but thank you so much, Tim, for that. Just a question, just to ask, what's really beneficial for Cade and yourself as part of this research in terms of industry engagement? So in terms of, you do the speaking, you're the sort of the speaking figurehead along with a few of your colleagues. But obviously we talk a lot internally in the university. What about externally, facing a lot more organisations, emerging practitioners and so on? Yeah, so the two kind of interactions we're very interested in with industry is, one, access to problems, and that's access to people, so people who've got problems and bring us case studies. So unlike some research, a lot of research is going on in digital ethics now, which is around constructing frameworks and this high level stuff. We're trying to be a bit more applied and really look at how those frameworks fit to problems and do it. So access to people in companies who are interested in these problems. And then the other way is kind of from a teaching perspective, which is, we've got a new subject starting next semester called AI Ethics and Law, which is a breadth undergraduate subject in Melbourne. We're also working on a master's subject as well for next year. But that's not directly with industry, but those people are going to go out hopefully with the training and take that knowledge into companies when they go. So that's sort of the impact we're having outwards from a teaching perspective as well. Wonderful. Yeah, thank you. Look, we will publish out the pub lunch talk that you've got coming up, but obviously, as I mentioned to Simon, this won't be the last time that that obviously we have Cade representation throughout the Melbourne Connect events program for this year. And we've got people who do have some questions about it, but obviously please do engage with either Melbourne Connect or Cade through Twitter stream, same as with Complex Human Data Hub, because we'd love to find a way to connect you two together if you've got further questions. So with that, we're getting towards the end now, so we'll wrap up. Melbourne Connect's going to continue having events very, very continuously, both in terms of this Connected You stream. This will run monthly, and it will run in the lunchtime period, but some of the upcoming topics include the future internet, entertainment, privacy, and so on. So we do have some really exciting topics and some really unique case studies coming up of, I guess, that interaction between humans and technology. Furthermore, thank you, Zara, for being involved. You produced a graphic recording, which is fantastic. We're going to share it out afterwards. We'll do that via email. But Zara's got her screen here. There you go. So Tim, you've had the pleasure of having an avatar created of yourself in the past already. So there you go. You get another one. But as you can see there, Zara's taken the liberty of following along with the conversation and then infusing a lot of these concepts that we've discussed throughout and basically letting everyone know about it. So we'll publish this out through the social channels. Someone's asked where you post this video again. Melbourne Connect has a YouTube channel. We will publish this. We will put it through post-production for a few title treatments and then basically publish it online so it can be shared out further. We'll promote out through our social media channels so you know when that is. But look, without further ado, thank you, Zara, for producing that. It's fantastic. Thank you very much to Associate Professor Tim Miller of Centre for AI and Digital Ethics and to Professor Simon Dennis of the Complex Human Data Hub. Really appreciate your time. Next Wednesday, we will have an event called Advancing Environmental Sustainability. It's available on our Facebook and also we'll be publishing it out through our newsletters. So sign up and we'll chat to you soon. Thank you all so much.